Hello friends, welcome back to Skill Raptor. This is your host Atharva. Last lecture we saw how to find percentiles, and this lecture and henceforth we are going to study what are the different types of distributions in probability. But to move ahead, I thought let me discuss first of all what is the simplest form of a distribution. That is nothing but discrete uniform distribution. We will be looking at mean and variance, how it looks like when we do an experiment and plotting a bar plot, and all that we are going to see in R. So please kindly look at this video till end because there are some important functions which I will be discussing while you plot a bar plot. Please kindly like, share and subscribe to my video. So the starting with our today's topic. So what is discrete uniform distribution? So as you can see, the name itself suggests a lot of things about this. Discrete means there are individual outcomes of an experiment. For the sake of simplicity, we will be looking at rolling a die. So when you roll a die, there are six possibilities you can get. That is either it will be 1, 2, 3, 4, 5, or 6. And it is uniform distribution. The reason is whenever we roll a die, the probability that we get from anything from 1 to 6 is same, that is 1 by 6. Now what is the mean and variance of this kind of a experiment and how to plot a bar plot using this? So let me show you how you can do a experiment, that is rolling a die, by using the R. So first of all, I will be calling a library called PUR, PU triple R. So just type library PU triple R, press enter. So my this library is called up. Now what I will do, I will define a variable that is X and I will store the values of this experiment. Now say for example I am rolling a die for 10 times and I will be getting anything out of 1 to 6. It may be any number from 1 to 6. So how to do that? So there is a command called rdunif bracket. The first number is the number of times I want to do experiment, that is 10. So 10 times I am rolling a die. The highest number is 6 and lowest number is 1. That is the syntax of this. I am pressing enter. Now our experiment is performed. Let me see how what are the numbers. So I will just type X and press enter. You can see these are the 10 different values which are generated, which are out of 6 and 1. Now let us find the frequency at what exactly, how many times a number is generated. So for that I will type table X. Now you can see these are the frequency table. So 1, 2, 3, 4, 5, and 6, and how many times a number was generated. Now ideally, if you see, I should get a bar plot where all the probabilities are 1 by 6. Now let me just see how, if I divide num x, table of x divided by length of x. Now these are the probabilities which I got. But in real life, if I see, the probability of getting every digit is 1 by 6, right? But it's not, it doesn't look like that, because see, if you see 2, you are getting it for 0.3. The reason is because we have done experiments for only 10 times. Now I will show you the bar plot how it looks like. Bar plot, table of x divided by length of x, comma, comma, table of x. This will give us a bar plot. So you can see it should be somewhere between 0.15 to zero point 0.2. That's how we should get that graph actually. But why we are not getting this? The reason is the number of experiments are very small. The sample set is very small. Now let me show you what happens if I do the same experiment of rolling a die for 100 times. Let me show you. Okay, let me type the command once again. That is x equal to rd So I will do this for 100 times now. Let me scroll it 100 times. 6 comma 1. Let me press the enter. Now see, I have generated 100 numbers which resemble rolling a die for 100 times. I'm pressing Control L because I want to rub the board. So these are my numbers. Now let me plot it again. See, now you can see the values are stabilizing near 0.15. As I said that 1 by 6 is nothing but around 0.16. Now I will show you something interesting. When I start increasing the experiments, now I will do the same thing for 1000 times, and let us see how what kind of graph we get. See, it's actually stabilizing near 0.1516, around 0.16. That is the outcome which we should get actually. See, this is how you can actually do experiments. In R, we demonstrated how the discrete uniform distribution function is generated. So this is a discrete uniform function which we have generated for the experiment of throwing a die. And you can see for 1, 2, 3, 4, 5, and 6, we get almost a uniform distribution. That is, the probabilities are almost same. Now you can just increase the number and you will see eventually the graph will show you. See, so that is how the random, sorry, not random, discrete uniform distribution means, and this is the simplest form of the distribution function. After this we are going to see Bernoulli's distribution and binomial distribution in upcoming lecture. If you like the video, please kindly like, share, and definitely before doing everything, please subscribe to the video. Thank you very much.